The power of numbers with integer exponents, operations with powers, and the standard form of a number. Hey there! Today we are going to look at powers. There is something about powers that you already know and can use operations on. For example, in geometry, a is a length of a certain line segment. A squared is the area of a square with side a, and a cubed is the volume of a cube with side a. A power is written like this. Let's recall the definition of powers with integer exponents. The power of number a with an integer exponent n greater than 1 is the product of the n factors, each of which is equal to a. For example, 2 multiplied by itself 5 times can be written as 2 to the 5th power. The power of a with an exponent 1 is equal to a. Any number other than 0 to the power of 0 is equal to 1. Now let's expand our understanding of powers to powers with negative integer exponents. If n is a random natural number and a is a real number other than 0, then a to the power of negative n is equal to 1 divided by a to the power of n. For example, let's look at some cases. Pay attention to the last task and memorize this formula. All properties of powers with natural exponents are applied to powers with integer exponents as well. Namely, let's see how those properties are used to simplify expressions and find their values. Another example. And now, I'd like to invite you to the Museum of Microminiatures. Inside this museum, the smallest book in the world is stored. The width of the letters on its pages average to about 35 ten-thousandths of a millimeter. Here's another peculiar sight. A hole is made in a hair, inside of which a tiny rose with a stem width of 5/100ths of a millimeter is placed. Isn't that crazy? Now, how much is that in meters? It's very inconvenient to perform operations on these numbers. This is why very large or very small numbers are written in standard form. If x is written in the form of a product, where a varies from 1 to 10 and n is an integer, it is written in standard form. The mass of the Earth in standard form is written like this. And the mass of hydrogen is written like this. Operations that are performed on monomials can be applied to numbers written in standard form as well. Addition and subtraction are performed based on the distributive law. Now you know how to write very large and very small numbers in an extremely convenient way. Now, try solving all of these problems on your own.